Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Our discussion today is basically going to be centered around a problem set. And in our last discussion on the concept of arrangement of capacitors in a circuit, basically come up with the two specific arrangements which are defined. And in this case, looked at the concept of the parallel arrangement and the series arrangement. Now, in our previous illustrations, we had given a specific formula which are going to be used in representing capacitors which have been arranged in terms of a parallel consideration. And then for the second one, we had as well looked at the concept of a series arrangement, which basically gave us a particular formula for that. Now, I'm going to quote those one for this one so that we can use them in trying to evaluate our problem set. And that is going to form a bit of this problem evaluation, which is going to be our final bit as I promised. Now, in this particular case, I said that for capacitors which are going to be given in terms of a parallel arrangement, we're going to have effective capacitance given in terms of the summation of the specific capacitors which have been arranged in terms of this particular arrangement given as such. And this is going to be going on to the number of particular capacitors which have gone or have been given in that specific arrangement. Now, for the series consideration as well, we had considered three capacitors in particular. And I'd mentioned that for the two cases we're going to consider, particularly in case we come across, or we're going to consider in some cases whereby we're going to see that for this arrangement, as a formula we can use for the arrangement of capacitors, especially when they are two in number. But in this case, we're going to look at the representation for the series, which are given in terms of 1 over C equivalent to 1 over C1 plus 1 over C2 plus 1 over C3 for three capacitors in those specific arrangement. So in this case, from our evaluation, we're going to see that if we consider this specific circuit, we're going to see that it's going to consist of a combination of the two particular arrangements we had given, whereby this section of the circuit is going to consist of capacitors which have been arranged in terms of a parallel arrangement, whereas the combination of these 5 microfarads, the sum of this specific arrangement in the middle and this 4-1 is going to form a series arrangement. So therefore, for us to evaluate the total capacitance, we are going to consider the case of this specific arrangement in parallel, and then the sum of this one and this one is going to form a final bit for the arrangement of capacitors in terms of a series arrangement. So therefore, we're going to consider the two formula. And in this case, if we look at a requirement for this specific problem set, we are required to calculate the effective capacitance and then the charge in each capacitor given in this specific arrangement, and then the potential difference across each capacitor. So in this case, we're required to evaluate a C, which is an effective capacitance, C effective, and then we're going to find Q in each capacitor, and then lastly, we're going to look at the concept of a V given as such. So to start with, we are going to look at the arrangement of these specific capacitors in parallel. Perhaps we can consider this specific middle section, which is going to be giving us using this particular formula. So therefore, for a parallel arrangement, we're going to have a C effective given in terms of 1 all over 3. So the units which I'm going to indicate in this case are going to be in terms of microfarads. So we're going to have that one given in terms of, sorry for that. So it's going to be 3 microfarads plus, and then we're going to have the second one, 2 microfarads plus 1 microfarads given in this specific case. So this is going to give us a total of 6 microfarads for the arrangement in parallel in this case. And then we're going to see that for this specific arrangement in series, this is going to give us effective capacitance for the total arrangement of this particular circuit. And therefore, we're going to consider the series arrangement in this case. And this is going to give us 1 over C effective given in terms of 1 all over. So we're going to consider this 5, which is 5 microfarads, plus the sum of this specific capacitors which have been arranged in terms of a parallel arrangement, which basically were found to be 6 microfarads. So therefore, it's going to be 1 over C, which is 1 over 6, plus the last one, which is going to be 1 over 4. So in this case, these are going to be in terms of microfarads, and therefore we are going to find that effective capacitance. So from my side, I'm going to find this is effective capacitance, basically given in terms of 60 over 37, which basically, if we try to, so this is going to be in terms of microfarads. If we try to convert them to standard units, this is going to give me a value of 1.62 times 10 negative 6 farads given as such. So this is going to be effective capacitance for this specific circuit which we have given. So from our first case, then therefore we're going to assume that this is going to be our evaluation for the first case for effective capacitance. So if we consider the charge stored by these specific capacitors, then therefore this is going to be option 2. We said that charge is equivalent to capacitance times the voltage. So in this case, we have been given the voltage as 40 volts given as such. So we're going to find this specific effective, of course, capacitance by a multiplication of this specific capacitance by the voltage, which is going to be given as 1.62 times 10 negative 6 times, this is going to be 40 volts, or 40.0 volts, just as they have been given. And therefore, this is going to be giving us a value of, so I'm finding this one to be 6.4864 times 10 negative 5 coulombs given as such. So in case we find a different answer for the evaluation, kindly notify us in the comment section, as I've always been saying, so that we can do a rectification of this. But this from my end, this is what I'm going to find, subject to confirmation from your other side. So this is going to be the choice for 2 in finding the charge in each of these specific. So this is going to be basically the total charge which we're going to see in this specific case. But as we're going to see that each of these specific capacitors is going to be having a particular, of course, amount of this specific total charge. So they are going to be having it as a charge which is going to be shared amongst this specific capacitor. So in this case, we're going to see that the charge stored by this specific capacitor is going to be equal to the total charge in the circuit. And therefore, in order for us to find perhaps for the 3, then therefore this is going to be, or for rather, I can just give that one in terms of an example. So in our last example, whereby we had given the arrangement of capacitors in particularly a series connection, we had mentioned that the same charge is going to flow in all capacitors. Remember that when we were trying to evaluate the different voltage which are going to flow through the different capacitors in terms of the series arrangement, we had given the value for Q being constant, and therefore we're going to consider that the same charge is going to flow through these specific capacitors. If we try to consider this specific value for 5, this specific arrangement for parallel, and the 4. So this basically is going to be 5, a sum of 6 and 4. So for 5, 6, and 4, then therefore they are going to be having this same charge which is flowing through the circuit. Therefore, we are going to consider a fraction of that specific capacitance which is going to flow through this specific middle capacitors. For instance, we can do an evaluation for the ones which have been arranged in parallel, so that we can have a concept on what basically this is going to look like. So for the 3 microfarads, we're going to have the total charge flowing through this one as a fraction of 3 over 6 times the total charge, which we have found to be 6.4864 times 10 negative 6. So this is going to be negative 5 coulombs. And then the evaluation for that one, therefore, is going to give us 3.24 times 10 negative 5 coulombs. So this one respectively, so for this specific fraction, if we want to find for the 2 microfarads, then therefore this is going to be 2 over 6, and then times the total charge, which we have said is Q. For the 1 microfarad, this is going to be 1 over 6 times the total charge, which is Q. And basically this total charge, as I've said, is going to be the value of this specific amount which we have given. So you can do an evaluation and try to find out what those specific evaluations are going to give us for that specific concept of charge in each capacitor. So as we said, for 5, this is specific ones which we can do evaluation using this one. But for this one and this one, the same charge is going to flow through those specific, of course, capacitors. Now, for the last option, we're going to look at the concept of a potential difference across each charge. And for this potential difference, we have mentioned basically that we can find a potential difference by the ratio of a Q over C, which is the total charge divided by the capacitance. So in this case, the potential difference is equivalent to Q over C, given as such. And as we said, we have found Q to be 4864 times 10 negative 5 coulombs. And this is over the total capacitance. Of course, we try to consider the potential difference perhaps in each capacitor, then therefore we can do an example for one of them, which basically if we consider for 5 microfarads, then therefore this is going to be 10 negative 6. And this is going to give me a value of 12.9496 volts. So if we consider this one, this is going to be V for 5 microfarads. And then if we consider the second one for a 4 microfarads, this is going to be giving me a value of 16.2 volts. So we're going to use the same procedure in trying to find this one. And then we're going to see that for the 3, 2, and 1 microfarads, which are going to be capacitors in parallel, of course, this is going to be the difference between 40 and the sum of 16.2 plus 12.96, which is equivalent to particularly 10.84 volts. So you can just do an evaluation to find these specific answers. And of course, if we find a difference, as I've said, you can just notify us in the comment section. So I hope this has been a comprehensive way of trying to analyze the concept of arrangement of capacitors in a circuit. And that is going to form an overall set of this specific arrangement of particularly capacitors. So our next discussion is going to look at the concept of resistors, and that's going to form another concept under the concept of electricity and magnetism, particularly under capacitors. So check our description boxes for various links of other videos, and kindly subscribe and engage us in the comment section for other discussions under similar topics. So that is it for now, guys. Bye, God bless you. Catch us in our next video.